Hello everyone, welcome back from my channel. Today we are going to do the exercises from Cambridge Primary Science Workbook 5. 2.1 How are sounds made? Focus. Question number 1. Look at the drawing. Complete this drawing to show what will happen if you tap gently on the jar with a pencil. You will need to draw in the rice grains. Label all parts of the drawing. So, if we tap gently on the jar with a pencil, the rice grains only move or jump a little bit because there is less energy being transferred. Question number 2. Complete this drawing to show what will happen if you tap hard on the jar with a pencil. Label all parts of the drawing. So here, if we tap hard on the jar with a pencil, the rice grains jump much higher and scatter further because more energy is moving through the jar and the cover. Question number 3. Use the words in the box to complete the sentences. Vibrations, more, less, vibrate. Question A. When you tap the jar, it makes the rice grains vibrate. Question B. Vibrations travel through the jar and the plastic rub to the rice. Question C. The rice grains move less when you tap the jar gently. Question D. The rice grains move more when you tap the jar hard. Practice. Sarah and Sophia listen to sound through different materials. This is the bar chart they drew to show how loud the sounds were. Use the bar chart to answer the questions. Question 4. Is the material through which the sound was loudest a solid, a liquid, or a gas? Solid. Question 5a. Sarah and Sophia also listened to sound through a woolen hat. The loudness of the sound was 3.5 decibel. Draw another bar on the bar chart to show this. So here we will draw another bar for the woolen hat. Question B. Is wool a solid, a liquid, or a gas? A solid. Question 6. Which kinds of materials on the bar chart do sounds travel through best? Solids. Challenge. Sarah and Sophia investigated how well sound travels through different materials. They listened to the sound of a clock ticking through the materials to see how loud it was. These are their results. Question number 7. Identify the control, independent, and dependent variables. The sound from the clock is a control variable. The material that they listen through is the independent variable. The loudness of the sound is the dependent variable. Question 8. Which materials did sound travel through best? Wood. Question 9. Which materials did sound travel through worst? Water and air. Question 10. Do you think Sarah and Sophia's results are accurate? Explain why or why not. No. Sarah and Sophia's results are not accurate because they did not keep the distance between the clock and the material the same, so this was not a fair test. Question 11. What should Sarah and Sophia do to get accurate results? They have to make sure the distance between the clock and the material is the same each time they measure the volume of the sound. 2.2 Volume and Pitch. Focus. Question number 1. Draw a line from each of the sounds shown on the drawings to match its volume. 110 decibel, 70 decibel, 100 decibel, 120 decibel, 60 decibel, 0 decibel. Question number 2. What unit is the volume measured on the drawing? Decibel. Question number 3. Which of the sounds shown do you think has the highest pitch? Baby crying has the highest pitch. Question number 4. How loud do you think a Formula 1 racing car is? Is it softer than, the same as, or louder the sounds A, B, and C below. A is softer than a Formula One racing car. B is the same as a Formula One racing car. C is louder than a Formula One racing car. Practice. Marcus and his friends use a rating system or ticks to record the volume of sounds they heard during their lunch break. These are their results. Question number 5. Draw a bar chart of the results. Remember to give your bar chart a heading and clearly label the bars and the axes. So here, this is a bar chart of the results. Question 6. How could the boys have made more accurate measurements? They could have used a sound level meter. Question 7. Identify the control, independent, and dependent variables. The control variable is a rating system or ticks they use to describe the volume of sound. The independent variable is the source of sound they measure. The dependent variable is the volume of the sound. Question 8. Which sound was the quietest? Talking sound. Question 9. How are the vibrations different as the sound gets quieter? The vibrations become smaller. Question 10. Describe how pitch vibrations are different to volume vibrations. Pitch vibrations are fast or slow, whereas volume vibrations are big or small. Challenge. Sarah and Sophia measure the sound volume of a clock ticking through different materials. These are their results. Question 11. Draw a bar chart of the results. So here is a bar chart of the results. On the x-axis, there is for materials, and on the y-axis, there is for volume in decibel. Question 12a. Which material did sound travel through best? Metal. Question B. Explain why sound travels well through this material. Because metal is a solid, particles are close together in a solid, so they bump into each other and vibrate more. Question 13. Identify the control, independent, and dependent variables in this investigation. The control variable was a sound level meter. The independent variable was a material. The dependent variable was the measured sound volume. Question 14a. Write a conclusion based on the data. Sound travels best through solids, especially metals, and worse through air. Question B. How could Sarah and Sophia make a more accurate conclusion? They can test more solids, liquids, and gases to get more accurate data. 2x3. Changing the volume of sound. Focus. Question number 1. What is volume of sound? Volume is a measure of how loud or quiet a sound is. Question number 2. Give an example of a loud sound. For example, thunder, traffic, aircraft taking off. Question number 3. Give an example of a quiet sound. For example, whisper, rustling leaves. Question number 4. How does the bell in the picture make a sound? When we make the bell shake from side to side, then the clapper will bang against the side of the bell. Vibrations travel from the bell through the air into our ears. Question number 5. Suggest as many ways you can think of to make the sound of the bell ringing louder. You can write or draw your ideas. We can shake the bell harder. Practice. My sister phone beeps all the time when someone leaves a message. How can I make it quieter, Sarah? Maybe you should write it up in a cotton t-shirt, Sophia. Question number 6a. Which material did Sophia suggest to muffle the sound of the phone? Cotton. B. List 3 other materials that Sarah and Sophia could test. Newspaper, woolen fabric, cotton wool. Question 7. Write down 2 other pieces of equipment and apparatus that they will need to make it a fair test beside the materials to test and the mobile phone. A sound level meter. Question 8. Name the control variable in their investigation. Explain why it is the control variable. The sound made by the phone and the distance from which they measure the loudness of the sound. These are control variables because they do not change. Question 9. What is an independent variable in their investigation? Explain why it is an independent variable. The material being tested is an independent variable because it changes during the investigation. Question 10. What is a dependent variable in their investigation? Explain why it is a dependent variable. The volume of sound is dependent variable because this is what they measure. The volume will depend on which material they are using to muffle the sound. Challenge. Question 11. Make a drawing to show how Sophia could use a sheet of card to make sounds louder. So this is a photo of Sophia can use a sheet of card to make sounds louder. Question 12. Explain how your idea will help Sophia to hear sounds louder. The air particles inside the cone cannot spread out, so they keep bumping into each other and vibrating. When you speak into the cone, the air particles vibrate more and the sound gets louder. Question 13. What could you do to improve your design so that it traps more sound and directs the sound better into her ear? If the card is rolled into the cone with the end farthest from the ear as big as possible, it will trap and direct more sound vibrations into the ear. 2.4. Changing the pitch of sound. Focus. Question number 1. Look at the pictures of Sophia playing the recorder. Complete the sentences about the pitch of the note Sophia plays. Use the words in the box. Lower, higher, slower, faster, low, longer, shorter, vibrations, high. When Sophia covers fewer air holes with her fingers, it makes the column of air into the recorder shorter. This makes the air vibrate faster and gives the sound a higher pitch. When Sophia covers more holes with her fingers, it makes the column of air in the recorder become longer. This makes the air vibrate slower and gives the sound a lower pitch. The speed of the air vibrations changes the pitch. The pitch can be high or low. Practice. Aaron has made a guitar. Look at the pictures A, B, C, and D of Aaron's guitar. So far, he has only put in one string. Suppose Aaron presses on the string at point X and then plucks the string between X and Y. Question number 2. What is pitch? Pitch describes how high or low a sound is. Question number 3. Will the pitch be highest when the string is plucked between X and Y in drawing A, B, C, or D? Explain why. In drawing A, the distance between X and Y is shorter than in drawings B, C, and D. The shorter the string, the higher the pitch. This is because vibrations are faster in a short string. Question number 4. How will the pitch of the sound change if the guitar string is thickest? The thicker string will give a lower pitch. This is because thicker strings vibrate more slowly than thinner strings. Challenge. Sarah made the musical instrument in the picture. She filled some bottles with different amounts of water. To play the instrument, Sarah blows across the tops of the bottles. Question number 5. What type of musical instrument is this? A wind instrument. Question number 6. Which bottle, B, C, or D, will produce a sound with the lowest pitch? Explain why. The bottle B. The lower the level of the water, the longer the column of air in the bottle. Question number 7. Which bottle will produce a sound with the highest pitch? Explain why. The bottle D. The higher the level of the water, the shorter the column of air in the bottle. Question number 8. Sarah wants to put water in the empty bottles A and E. A. Show the level of water she must pour into bottle A to make a lower pitch than B. So this is a picture of bottle we draw. Question B. Draw the level of water she must pour into bottle E to make a higher pinch than T. So this is a bottle of water we must draw. Question 9. Look at the picture of a drum. How do you think you can change the pinch of the drum? The drum has a skin stretch over the top. You can make the pinch higher by tightening the nuts around the outside of the drum. You can make the pinch lower by loosening the nuts.